In this webinar, I will begin by introducing 3Peak. After setting the stage, I will provide an overview of heat pump applications. Following that, I will dwell into the specifics, exploring which products from 3Peak's portfolio can be seamlessly integrated into the heat pump systems. 3Peak overview. 3Peak stands at the forefront of analog signal chain and power management IC solutions. As a fabless semiconductor company with dual headquarters, one in Suzhou, China, and the other one is Plano, Texas, our operations span the globe. We are supported by a leadership team with a wide-ranging international experience and perspective. Our passionate workforce of over 830 professionals drives innovation, with more than 62% dedicated exclusively for the research and development. This commitment to breakthrough technology is reflected in our robust R&D investments, approximately $81 million, which accounts for about 47% of our revenue in 2024. And also further, it's also further reinforced by our growing portfolio patents. We are serving more than 6,000 customers worldwide across four major sectors: automotive, industrial, communications, and new energy. We offer an extensive range of over 980 products tailored to the nuances of signal chain and power management domains. Our comprehensive solutions consistently meet the evolving demands of modern industries, paving the way for continuous technological advancement. As previously mentioned, 3Peak boasts a truly global presence. Our research and development efforts are largely centered in Asia, with dynamic hubs in China and Singapore, driving innovation and technological breakthroughs. At the same time, our strategic presence in the Americas and Europe ensures we remain near our customers, offering tailored, responsive support wherever they are required. In particular, our Suzhou facility houses a state-of-the-art automotive test plant. This high-quality facility underlines our commitment to automotive excellence, rigorously testing our products to meet the stringent demands of the industry and ensuring that our solutions deliver reliable high-performance results on the board. Amid today's complex geopolitical landscape, 3Peak proudly showcases its resilient supply chain strategy. We are a fabless company and we capitalize on industry-leading manufacturing partnership on a global scale. Our robust relationships with a network of carefully selected fabs across diverse regions ensure that we deliver competitive lead times and maintain flexible manufacturing flows for our customers. Although the majority of our back-end facilities are currently concentrated in Asia, we are actively exploring additional partnerships to further strengthen our supply chain and extend our global reach. At 3Peak, we offer products which adhere to the world-class quality and support. Our commitment is to deliver cost-effective, defect-free, and error-free products. We adhere to ISO 9001 and IATF 16949 quality management standards, and we align with the JDEC and AACQ standards. We manage products or process changes as required, handle the scrap efficiently, and provide on-site quality surveys. Our environmental policies meet ROHS, REACH, and ELV standards. Coming to our lab capabilities, from chip level to wafer level testing, we ensure rigorous quality control. At the same time, we confirm that our products meet the operational demands of the intended applications. Our facilities support thorough failure analysis and reliability testing to guarantee long-term performance. Our broad portfolio, when it comes to 3Peak's offerings, we have both standard catalog and application-specific products. The lineup includes nearly everything surrounding the microcontrollers, excluding sensors and actuators. Under the linear product category, 3Peak provides operational amplifiers, instrumentation amplifier, and HV currents or high voltage currents and amplifiers. The converter portfolio features precision ADCs and DACs. In the interface segment, you will find RS232, RS485 CAN-LIN interface ICs, digital isolators, and isolated gate drivers. For power management, there are voltage references, LDOs, and DC-DC converters. Lastly, in the driver product category, 3Peak offers DC motor drivers, stepper motor drivers, and gate drivers to drive silicon carbide and also the gallium nitride switches. What is heat pump and how does it work? A heat pump is a device that transfers thermal energy between two locations by leveraging principles similar to those used in the refrigeration systems. However, it works in a reverse when compared to a typical air conditioner. Instead of generating heat through fuel combustion or electrical resistance, a heat pump extracts the warmth from a cooler surface, maybe such as outdoor air, ground, or water, and moves it to a warmer space, be it inside your home or even in a vehicle cabin. At the heart of this process is a refrigerant. A refrigerant is a special fluid, and especially in this case, we will select a refrigerant that evaporates and condenses at low temperature. During colder months, the heat pump draws thermal energy from the outside environment, transferring it inside to the building. Conversely, in the summer, it can cool our interiors or the maybe the cabin or the building by extracting heat from indoors and releasing it outside. The operation begins as an external component of the heat pump blows or pumps ambient heat over its heat exchange surface. This transferred heat is sufficient to cause the refrigerant to evaporate into a gas. Then this gas is passed through a compressor, which elevates its pressure, and consequently, its temperature would be increased. This heated gas is circulated over the internal heat exchange surface, where the stored energy in the gas is released into the interior of the building. As the refrigerant loses its heat, it cools down and condenses back into the liquid, and the new cycle will begin. Throughout this process, electricity is not used in generating the heat directly. Rather, it powers the system that moves energy from the surroundings into the other place where either heating or cooling is required, making the heat pump an efficient and sustainable heating and cooling solution. What are the benefits of the heat pump? Why there is a huge buzz around the heat pump? One of the standout advantages of heat pump is its remarkable energy efficiency. Unlike conventional electrical heaters that create heat by converting electrical energy directly, heat pumps operate by transferring ambient heat from one location to another. Their performance is captured by the coefficient of performance, a metric which measures the ratio of useful heating or cooling output to the electrical energy consumed. Typically, a heat pump will have a COP between 3 and 4, indicating that it transfers 3 to 4 units of heat for every unit of electrical energy consumed. Typical ratings of these residential heat pumps would be around 4 to 6 kilowatts, and that of an automobile could be around in the same range. But yeah, typically, we have seen that in automobile it's about 11 kilowatts or 13 kilowatts. Since heat pumps do not rely on burning fossil fuels, they significantly reduce the overall carbon footprint. The other main advantage is they offer dual functionality. That is, in winters, they extract heat from the cold outdoor environment to warm interior spaces. And in summer, by engaging a reversing valve, they reverse the process to effectively cool the inside area. Additionally, heat pumps can be integrated with renewable energy sources such as solar power to further enhance their sustainability and operational efficiency. There are several types of heat pumps, each designed for different needs and environments, like air to air heat pumps, air to water, and geothermal. Air to air, these systems collect heat from the outside air and transfer it directly into the conditioned space. They are among the easiest to implement and are the most common type in United States. However, their efficiency is slightly limited due to air's lower density and heat capacity compared to soil or water. Air to water heat pumps, it's more common in Europe. These systems typically feature an outdoor unit. The outdoor unit typically consists of evaporator, expansion valve, and a compressor. and an indoor unit which includes a condenser or heat exchanger along with circulation pump and a water tank. The condenser heats the water which is then distributed throughout the home for heating purposes. Geothermal heat pumps, these systems leverage the relatively constant temperature of the earth to provide effective heating and cooling, particularly in the areas with extreme weather conditions. Their consistent performance make them a reliable option in regions with significant temperature fluctuations. This innovative approach not only provides efficient heating and cooling, but also aligns with broader environmental goals by reducing reliance on fossil fuels and minimizing the greenhouse gas emissions. Coming to the typical block diagram of the heat pump, this block diagram provides a detailed overview of electrical architecture in a heat pump's outdoor unit, highlighting key components and power flow. From a single phase AC, or it can be a three-phase AC, depending on the power rating of the heat pump, an AC-DC converter is implemented to generate system voltages. For cost-optimized control loops, we could use TPR433, that is a voltage reference, to ensure accurate regulation of the converter. The output will be typically a 24-volt DC rail, which serves as an intermediate bus voltage. A 3.3 volts, which is required for the MCU, is derived from this 24 volts using a buck converter and an LDO, depending on the system's efficiency and noise requirements. In order to support the IPM, that is the Intelligent Power Module driving, either we could have plus minus 15 volts in case of IGBTs or in plus 15 and minus 4 in case of a silicon carbide MOSFET. These symmetrical or asymmetrical rails could be generated from a flyback converter followed by an LDO. Motor control is central to this system due to multiple fans and compressors. We can expect to integrate a variety of op-amps or comparators and gate drivers tailored to the safety and control logic of the application. For relay and solenoid valve actuation, TPM 2003C transistor array offers compact, reliable switching. To ensure robust power sequencing and fault detection, 3-peak supervisory ICs monitor key MC or monitors the power supplies of the MCUs. Through our partnership with Ineltek, the system can be further expanded with Nuvoton's MCU, for example, in this case KM1M7, which supports dual fan control and a PFC regulation. FMD memories round out the system to meet the storage and code execution needs. Inter-unit communication is achieved via RS485, ensuring reliable noise-immune data transfer between outdoor and indoor systems. All the highlighted components here are like this diagram is a typical block diagram, and the components which we highlighted are 3-peak field-proven components used in the similar applications. This slide shows the block diagram or outlines the electrical components of heat pump's indoor unit, which shares nearly identical architecture with the outdoor unit in terms of power supply and signal conditioning. The key differentiator lies in two areas, that is the human-machine interface control. The indoor unit typically integrates an HMI controller to manage user interaction and display system status. This adds another layer of MCU and peripherals integration compared to the outdoor unit. And the wireless connectivity. Connectivity options like Wi-Fi or BLE, that is the Bluetooth Low Energy, are embedded for smart communication and integration into the home automation system. These subsystems require dedicated interface and careful signal isolation. For communication and signal integrity between different logic level domains, 3-peak offers digital isolators tailored for such applications. Moving ahead, I would like to touch on three important or key parts from 3-peak. The first one is TPT 774X series. It's a digital isolator that quietly powers some of the most demanding industrial systems out there. At its core, the device is all about reliable high-speed communication across isolated domains. We are talking about a 4-channel enhanced digital isolator rated for up to 5 kilovolt isolation, which gives you enough headroom in high voltage environments. Whether you're working with PLCs, motor drivers, heat pumps, or power conversion systems, it's built to hold steady high voltages. Now, here is where it gets interesting. The TPT774X supports data rates up to 150 Mbps with a typical propagation delay of 12 nanoseconds. That level of precision matters when timing is really tight, maybe in the PWM control or in the synchronized feedback loops. Add to that, the channel to channel skew is under 2.5 nanoseconds, and the maximum part to part skew is 5 nanoseconds. Then the question arises, how about the resilience? This device boasts about static CMTA of 200 kilovolt per microsecond and a dynamic CMTA of 150 kilovolts per microsecond, making it a great fit for industrial noisy environments. And even with this performance, it just draws 3 milliamps at 1 Mbps, which is a bonus for systems that balance speed and energy efficiency. We have got the packaging flexibility as well. This family of devices are available in SOP, QSOP, and WSOP versions, so integration will be a bit smooth regardless of the board constraints. In real world terms, you can use this isolator in maybe in the solar inverters, servo systems, power supplies, heat pumps, or anywhere we need fast and safe signal isolation. The next product which I would like to highlight is TPP36208 from 3Peak. It's a high performance 2 amp synchronous step down regulator designed for systems that demand robust power delivery with minimal footprint. Starting with the input range, it's a bit generous. It's a wide V input range step down converter. It can handle anything from 4.5 volts to 36 volts, withstanding surges up to 42 volts, which is ideal for industrial setups. It has integrated 180 milliohms and 90 milliohm MOSFETs, and it could withstand 2 amps or it could support 2 amp current. From the efficiency standpoint, this part requires or it just draws 70 microamps in the active mode, that is the quiescent current, and when it is shut down, it consumes as low as 2 microamps. This is really compelling for designs where battery life or thermal limits matter the most. We have got three switching frequency options: 500 kilohertz, 1 megahertz, and 2.2 megahertz, giving room to optimize for board space, EMI, or transient response. And in case of a light load conditions, we have got two options. One is the devices with pulse skipping mode and the devices with force PWM mode. Pulse skipping mode is used in designs where you would like to optimize or maximize efficiency when the load is low, and you would opt for a force PWM mode when you would like to keep the inductor current ripple under tight regulation. These devices are housed in SOT23 6-pin package, and we only need few passives like couple of capacitors, couple of resistors, and an inductor to get it up and running. This makes an excellent fit for distributed power rail designs in both industrial and commercial electronics. Before we close today's session, I would like to leave you with a quick look at another standout device from TPIC, that is TPM2003C. This is a compact but powerful 7-channel Darlington transistor array designed to handle up to 500 milliamps per channel. And if the design demands more drive current, we could easily parallel the channels to scale output as required. It's really robust and it could withstand voltages up to 50 volts, making it a strong fit for industrial application. What really makes 2003C shine is it has got integrated freewheeling diodes, which makes it ideal for the controlling the inductive loads like relays, solenoid valves, or motors without needing extra protection circuit. It does not complicate our layout either. It comes in well-known SOP16 and TSSOP16 packages, making it easy to drop into compact boards or space-constrained designs. To quickly recap, we have introduced TPIC and its versatile product portfolio, highlighting how our high-efficiency analog and power management solutions can significantly improve the performance and system efficiency of the heat pump designs. Together with our partner Ineltek, we offer a comprehensive one-stop solution for the entire heat pump ecosystem, spanning from analog ICs, power management ICs, microcontrollers, and memories. If you have any further questions, yeah, or would like to explore these solutions in detail, please don't hesitate to reach out to us. Thank you for joining us. And if you have any questions, open for this one.